Let us solve a question on cournot Nash equilibrium. The question is, let market demand faced by duopolists be P is equal to 100 minus 0.5 Q. P denotes the price, Q denotes the output of the two monopolists. That is, Q is equal to Q1 plus Q2. That is the output produced by firm 1 and output produced by firm 2nd. And their respective cost functions are being given as is. That is cost function of firm 1 is 5Q1 and cost function of firm 2 is 5Q2. Okay, so since we have the cournot duopoly model, means we have only two firms in this case, we have to find out the cournot Nash equilibrium. Okay, so let us write the given demand function as P is equal to 100 minus, then we have 100 minus 0.5. In place of Q, let us write Q1 plus Q2. There is Q1 plus Q2. So rewrite it like this: P is equal to 100 minus 0.5 Q1 minus 0.5 Q2. This is the inverse demand function. Also, we are being given here that is cost function of firm 1 is equal to 5Q1 and cost function of firm 2 is 5Q2, or let's write it like this: C2 is equal to 5Q2. Okay, since we have the duopoly model, that is cournot duopoly model, in this case firms compete in terms of quantity produced or supplied. Okay, so the only competition is the output, not the price here. So firms compete in terms of quantity. To find out the cournot Nash equilibrium, we need to find out the reaction functions of firm 1 and firm 2. Okay, so let us find out the reaction function of firm 1. I will explain what exactly is meant by reaction function. Let me first derive the reaction function. To find out the reaction function of firm 1, we need to find out the profit maximizing condition for firm 1. That is, profit maximizing condition for firm 1 will be that it will equate the marginal revenue with its marginal cost. That means we need to solve this in first we need to find out the total revenue function. Then, so total revenue, as we know, it will be equal to P into Q1. So P is being given us as this very function, that is 100 minus 0.5 Q1 minus 0.5 Q2. To this we multiply Q1. So this will be the total revenue function of firm 1. Now we need to find out the marginal revenue function of firm 1, or if we rewrite it first, so total revenue of firm 1 will be equal to, multiplying Q1 to each of these terms, we get 100 Q1 minus 0.5 Q1 square minus 0.5 Q1 Q2. Okay, now we can find out the marginal revenue of the firm 1. So marginal revenue of firm 1 will be the partial derivative of the total revenue function with respect to output Q1. Differentiating this with respect to Q1, derivative of Q1 is 1, so we are left with 100. Derivative of Q1 square is 2Q1, so 2 becomes coefficient, so 2 into 0.5 is 1, so we are left with only Q1. Minus derivative of Q1 in this will be 1, so we are left with 0.5 Q2. This is the marginal revenue function. Marginal revenue of firm 1 comes out to be 100 minus Q1 minus 0.5 Q2, and marginal cost is the derivative of cost function of firm 1 with respect to output. So marginal cost will be the derivative of this function with respect to Q1. Derivative of Q1 is 1, so we are left with 5. So implies marginal cost of firm 1 is equal to 5. Now we equate the marginal revenue with the marginal cost. That means marginal revenue 1 is equal to marginal cost of firm 1. Marginal revenue is 100 minus Q1 minus, let's write it here, 1 upon 2 Q2 should be equal to the marginal cost, which is 5. So transposing Q1 here, so we will get Q1 will be equal to 100 minus 5 is 95 minus 1 upon 2 Q2. This is what we call the reaction function of firm 1. It shows how does firm 1 decides its output given firm 2 decides its optimal output. Okay, in simple terms it says that the optimal quantity chosen by the firm 1 given firm 2 has chosen its optimal quantity. Okay, so that means if firm 2 changes its optimal quantity, firm 1 will choose its quantity accordingly. Okay, so this is the reaction function. How does the firm 1 react given the firm 2 has reacted by its optimality? Okay, this is the reaction function of firm 1. Similarly, we need to find out the reaction function of firm 2. Very simple. So when we find out the reaction function of firm 2 by symmetry, what will we get? So RF2 we will get Q2 will be equal to 95 minus 1 upon 2 Q1. Okay, I left you as an exercise to find out this reaction function of firm 2. Okay, so to find out the reaction function of firm 2, proceed this way. In this case, you have to find out the marginal revenue of firm 2 and you equate it with the marginal cost of firm 2. Okay, then you solve, you will get this very reaction function. If I draw the graph here a little bit, if I can draw it here, so let us say this is Q1, here we have Q2. If I draw the graph of this reaction function, so graph is not visible, let me be in my limits. So let us say we have Q1 on the horizontal axis, Q2 on the vertical axis. If I draw this graph, so when Q2 is equal to 0, Q1 will be equal to 95. Okay, so we will get, let us say this is RF1, and in this equation when Q1 is equal to 0, Q2 is equal to 95. Okay, let's draw it like this. Okay, I'm just drawing it roughly here. So our reaction function of firm 2 will be like this. So this is RF2. You can draw the graph of these two equations. It will look like this. So optimal quantity will occur where both the reaction functions intersect with each other. That means when RF1 is equal to RF2. So reaction function of firm 1 is this, reaction function of firm 2 is this. So what will we do? Let us plug the reaction function of firm 1 into reaction function of firm 2. Okay, to find out the optimal quantity. So Q2 will be equal to 95 minus 1 upon 2. Q1 is again 95 minus 1 upon 2 Q2. We need to solve. So Q2 will be equal to 95 minus 1 upon 2. So it will become, and let me show it here. So it becomes 95 upon 2, minus into minus is plus. We get here Q2 divided by 4. Okay, let us solve this for Q. Why I am not having the space here. So let me rub this out here to solve this. For Q2, transposing this here, so Q2 will be equal to Q2 minus Q2 upon 4 is equal to, solving this, 95 minus 95 upon 2. Okay, so it becomes 190 minus 95 upon 2, which comes out to be 95 upon 2, I guess. So this is so 3 Q2 upon 4 is equal to 95 upon 2, which implies Q2 will be equal to 95 upon 2 times 4 upon 3 when we transpose this. So 2 1s are 2 2s are 4. We will get Q2 is equal to 190 upon 3. This is the optimal quantity of firm 2. Similarly, to find out the optimal quantity of firm 1, by symmetry, that will be also equal to Q1 will be equal to 190 upon 3. You can check this out by plugging the value of Q2 is equal to this stuff into reaction function of firm 1. Okay, so cournot Nash equilibrium output will be that when firm 1 produces 190 upon 3 levels of output, and firm 2 also chooses 190 upon 3 units of output. Okay, that will be the cournot Nash equilibrium in this case. And you can also find out the equilibrium price here. Simply plug P is equal to, so we have this inverse demand function 100 minus 0.5 times Q1 plus Q2. So Q1 is 190 upon 3 and Q2 is 190 upon 3. Solve this, you will get the market price. I hope I make myself clear in this video. Thank you.